Alright, so this is our heating curve. We're heating up a substance, we're adding energy to it, looking at the temperature, and comparing what happens to the physical states during that process. So if we're in a solid state below, well below, down this way, down this way, below its melting temperature, then we can heat up the solid. Once we reach the melting temperature, then adding heat doesn't change the temperature while it's melting. It's putting all that energy into getting those structural particles to unlock from each other. They can move around each other in a liquid, but they're still touching. In the solid state, they're not only touching, but they're stuck in place around each other. Okay? Alright. So once we have all of the substance melted, then the temperature can rise again. And so while we're in that liquid state, then the temperature continues to go up. So this is the heating up the liquid. If we're going to the right anyway, we're heating it up. If we're going back this way, we're cooling it down. Okay? And then finally we'll get to a point where we reach the boiling temperature. Okay, so that's the boiling temperature here. Alright, so here's our freezing temperature here, and the melting temperature. And this is our boiling and condensing temperature. Alright? Now, while we're transferring or translating, we're boiling, we're changing from liquid to the gaseous form, this temperature doesn't go up anymore. During that time, we have another plateau. And then once we get everything into the gaseous form, well, then we can continue to raise the temperature. So this region here, this is where we're boiling. Or if we're removing heat and going back in the other direction down here, so if we're adding energy, we're increasing the heat into the system. If we're removing heat, we're going in this direction. In that case, then we're not boiling, we're condensing. And so here now we're continuing to add energy, and it's causing the temperature to go up. So this is heating a gas. Okay? Now, every time we have these slopes, every time the temperature can go up, when we have a solid state while it's heating up, a liquid state while it's heating up, or a gas while it's heating up, we're using the same equation. That equation is Q equals mass times the specific heat for that substance in that state. Every substance has 3 different specific heats times the change in temperature. So that equation fits here, here, and there. But while we're adding heat to the liquid state to get it to boil, or taking heat away from the gas state to get it to condense, or while we're heating up the solid state to get it to melt, or the liquid state to get it to freeze, that uses a different equation. The temperature isn't changing. The temperature's not going up here during these two periods. So anytime we have a plateau, then the equation is Q equals mass times the change in enthalpy of the system. Okay, so that formula there goes in this area here and this area here. And then the specific heats, or the heat capacity, this CP, you don't have to memorize those. I'm going to give those to you. You don't have to memorize the delta H. I'm going to give those to you. Okay? You have to know where they fit. You have to know what the graph looks like and where to put those. Does that make sense? You know what's freezing, what's the solid state, what's condensing, where the gas state is. You have to know all that.
And the test is Monday, right?
Test is Monday. All right? Now, does that cover everything with this you wanted to know? All right, now, you wanted to have another question then for you to solve that just you solved, right? Basically using the same information.
No, not that information.
Oh, which one? Oh, the combustion reactions? Okay. Let's see. Huh?